Hi, today we're going to take a look at a program called Trajectory Analyzer, and this comes as part of the VTC package. The purpose of a Trajectory Analyzer is to review counts after a video is being processed by VTC. So this video is assuming you're already familiar enough with VTC to process a traffic video on your own. And if not, I'd recommend you take a look at our earlier tutorials on the basic setup for VTC. So this video is starting by assuming that you've already counted a video, and here's the output folder on our desktop. So we have this icon on our desktop after you've installed VTC called Trajectory Analyzer. I'm just going to launch that. And you can take this output folder from VTC and just drag it anywhere into Trajectory Analyzer. And you'll see the folder is being loaded right here. Okay, so let's just start by looking at all the movements that we counted in this video. Okay, so we can see here each one of these red lines, that's one vehicle. And the blue lines, that is a different path through this scene. So each red line is compared to the blue lines, and the nearest blue line dictates how that path is classified. Okay, so that might be a little abstract. Let's take a look at something specific. So, for example, approach 1. All of these red lines here are paths that were determined to be following the approach, to be originating from approach 1. So this here is approach 1, this is exit 1. All of these red paths are vehicles going straight from approach 1 to exit 1. So let's just take a look at an example here. Maybe let's say this one. So we can see this is the actual path that a vehicle followed, whereas this is the trajectory that is called approach 1 to exit 1. This is the definition of approach 1 to exit 1, the blue path. So this red path was determined. It was determined that this blue path is the closest to it as compared to this or this or this or this. So you can actually check that yourself. So these, when you highlight one of these matched trajectories, these yellow lines will display the distance of each point on the actual trajectory to the nearest point on the synthetic trajectory, which are these blue ones. These are called synthetic trajectories. Okay, so take a look at the yellow lines here and the average length from the red line to this first approach 1 to exit 1 synthetic trajectory. Now let's compare it to approach 2 to exit 2. So you can see the yellow lines there, they're way bigger. It's a lot farther to go from this red path to this synthetic trajectory, which represents approach 2 to exit 2. Let's carry on. That's even bigger, and the trend's going to continue. So this is going to look a little weird here, where the entire red trajectory is matched to this one point on approach 7 to exit 7. And what's happening there is basically every point on this trajectory is going to be matched to the nearest point on the highlighted trajectory here. So because this trajectory is quite far away and it's angled in this way, it's not going to match to anywhere else on it other than the last point on it. So that's why it's going to look a little weird here, but this actually is correct behavior. Okay, so let's take a look at another example, say all the approach 5 movements. Okay, so we can just go through all of the movements that were classified as being approach 5 here. And so let's take look at one that's a little bit marginal. So let's say that one. So here's our match to approach 5. Exit 5, and here's our match to approach 6, exit 6. And we can see that that's actually pretty close there. It's a little bit of a tough call whether that particular trajectory was on approach 5 to exit 5 or approach 6 to exit 6. So we can actually look at the numerical value of this match cost. If we just scroll over a bit here, this is basically the overall cost of that match. So the cost of matching to this is about 70. The cost of matching to this is about 100. So in terms of order of magnitude, they're fairly similar, but this one is a slightly better match in this case. So the purpose of Trajectory Analyzer, this tool, is, for example, you've counted a video and some turns are not being classified the way you expect. So the idea here is that using this tool, you can actually go in and look at the numerical classifiers, and you can see why is a particular movement being classified as a left turn or a right turn or lane 1 or lane 2. So hopefully that clarifies things. Thank you.